Hello class, and welcome to lesson 3.2, solving by substitution. That's going to be our second method on how to solve linear systems. However, we're going to do our warm-ups first and revisit method 1, what we learned last class, which is solving linear systems graphically. So it says, key steps for number 1. Describe how to solve the linear systems graphically. Well, first of all, you're going to create and label two equations if they don't have them. So I'll just say label equations 1 and 2. You got to be able to identify which one is which. Okay, so label equations. Then you're going to graph each line on the same grid. After you graph each line, you're going to locate the P of I, which is short form for point of intersection. And then don't forget to say your conclusion. Solution xy equals, etc., etc. Awesome. Okay, sorry, that looks bad. Conclusion, that looks like an O, but it's really a U. Conclusion, there we go. All right. Step 2, what concerns might arise that might make it difficult to use this method for solving? So there's two. One is the example I gave you yesterday about the banquet halls. Could we plot that on an XY grid? No. So the P of I, or the point of intersection, might be located outside of your graph, right? So let me just write that down. P of I may be located outside of grid area. Okay, so if I had like an XY grid here, and say you had your equations, one was going like this, and this one was going like this, but they haven't met, and they'd probably meet way over here, outside of your grid area. Okay? The second problem with graphing is what happens if we have our grid set up like this. So there's an XY grid, okay? And say we drew our two lines, and one went like this, and the other one went like this. Notice, folks, the point of intersection. It's not on what we call a grid hair. These red ones are called grid hairs. So this point of intersection, which lies right here, may not be accurate because you're going to have to estimate that fraction, right? Okay, so the point of intersection, okay, so P of I may not occur on grid hairs. And that's what makes that frustrating as well. Okay? All right. Any questions with that, folks? All right. Let's practice from yesterday, solving linear systems by graphing. So first of all, I'm going to go equation 1, and I'm going to go equation 2. Okay, and we can choose different methods to do whatever we want. So for the first one, by example, I'm going to use x and y intercepts. So to find my x-intercept, I'm going to let y equal 0. So I'm going to rewrite this. Wherever I see a y, I'm going to put a 0. So it's going to be x plus 4 times 0 equals 4. 0 times anything is 0. So I'm going to get that x equals 4. That means I've got the ordered pair now, 4 and 0. I can plot that on my graph. Please note, folks, the scale on this, my scale is 2 as opposed to 1. So just keep that in mind if you're trying to transfer over to your grid. Okay? But you can have a grid of 1, it'll still work. Okay, or a scale of 1, I should say. All right, let's find the y-intercept. So y-intercept, x equals 0. So it's going to be 0 plus 4y equals 4. 0 cancels out, and you got to get y by itself, so you divide both sides by 4. So y equals 1. So that would give us, folks, an ordered pair of 0 and 1 because it's x equals 0, x goes first. So on my y-axis, I'm going to put a 1. Okay. Now I've got my 2 points. I can draw my line. Ooh, I'm going to have to adjust it. Just give me 1 sec, folks. It'll look better in a minute. It's always tough when you've... There. That looks... you need to bring this part down a bit. There, that looks a bit better now. Okay. Again, got to make sure you got arrows on both sides. And you've labeled it equation 1. Okay. I'll actually put it in red for you guys so then you can match it, because I know people like things coded, so I'll put that in red for you. Okay, there's equation 1. All right, equation 2, folks, we can do things differently. I'm going to rearrange that into form y equals mx plus b. So y equals, take the negative 2x over, becomes a positive 2x, and plus 10 because the 10 stays where it is. Okay, so from that, what do I know? I know my b equals 10. That's my starting point. I'm going to plot that there. And then my slope equals 2 over 1. So from there, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2. Oh, I apologize. Up 2 over 1, up 2 over 1. My fault. Let's erase that. Start that one again. Yeah, I make mistakes too. So from there, ladies and gentlemen, we can go up 2 over 1. However, that's going to be hard to keep doing, so I'm going to do the opposite. So I'm going to go to the left 1 and down 2. Left 1 and down 2. It's the same step pattern, we're just going the opposite way. Okay, and sometimes that's going to occur. That's, again, another frustration, I guess, about graphing too. All right, let's draw this line in. Okay, give it an arrows at both ends. It's a little easier for you to do that than me. Make sure you label it equation 2. Okay. And ladies and gentlemen, find the point of intersection. So hopefully you've circled that. Go P of I. It's communicating that I know that's the point of intersection. And hopefully you're telling me it's negative 4 and 2. And then to finish off, you say therefore solution xy equals negative 4 and 2. Awesome. Now we're going to get into our second method of solving linear systems, which is called substitution. All right. Since solving graphically has some accuracy downfalls, a better way to solve is algebraically. Algebraically means we don't have a grid. We don't have to worry about if our point of intersection hits one of the crosshairs or not, or if it's outside of our grid altogether. We don't have to worry about that anymore, because there are 2 ways to solve, and today we're going to focus on the substitution method. Next class will be the elimination method. So here's the key for the substitution method. You're going to solve one equation for the first variable, then substitute it into the other. So we're going to sub one equation into the other, and then we can solve for the second variable. So the name itself will tell you what to do. So substitution means we're subbing one equation into the other to remove a variable. Some of these steps you'll notice are the same, but many are going to be different. So label equations 1 and 2. We're used to doing that, and you'll do that for all 3 methods. Now's the new stuff. We're going to rearrange one equation to isolate a variable. It can be x, it can be y, whichever one's easiest that does not create fractions or decimals, okay? Then we're going to substitute one into the other. And the big thing to realize is once you've substituted in, there's only going to be one variable remaining, and that's when you're going to solve a linear equation like we did in grade 9. And then what we're going to do is once we found that, we're going to sub that variable and sub it into the other equation and solve for the other ones. Then you're going to recognize this is the same, concluding statement, and check. All right. So example 1 says to solve algebraically. If it says solve algebraically, don't throw a grid on there. Even if you like graphing method, don't throw a grid on there. We're going to learn how to do this. Okay. And I'm going to help you through it. And I don't think you're going to find it so hard. And don't forget, we're going to check the solution. All right. So we got equation 1 and equation 2 labeled. Now looking at equation 1, we could rearrange that for y, for x, and substitute that way. Or we can take equation 2 and rearrange it for y. I'm going to do it equation 2 just because it's easier since it's going to be on the bottom and I can access it already. So I'm going to leave the y where it is. I'm going to take that negative 2x and bring it over to plus 2x. It doesn't matter if it's in the form y equals mx plus b. Okay? We just need to isolate or get one variable by itself. Okay. Once you've rearranged that, you're going to say sub, meaning substitute, whatever you've rearranged. So in this case, y equals 10 plus 2x into the other equation. So if we've rearranged 2, you're going to sub it into 1. If you took the x out of 1, then you would sub it into equation 2. You always shove it into the opposite. Okay? So folks, I'm going to rewrite equation 1, but wherever I see a y, just give me a second and I'll show you what I mean by that. Normally, I would have 4y. Don't write this down. But I'm going to take the y and I'm going to erase it. And wherever I see a y, I'm going to put the value of y from the other equation, which is 10 plus 2x. That's called substitution. And notice when I've subbed in, ladies and gentlemen, the y got replaced with 10 plus 2x. I no longer have any y's in here. So I'm going to solve for the x. I've got to use my mathematics from last year, so I know this is distributive law. So I go x plus 40 plus 8x equals 4. Okay, collect like terms. So I have 9x plus 40 equals 4. We want to get the x term by itself, so 9x equals 4. I'm going to bring the 40 over, change the sign to negative 40. So I now have 9x equals negative 36. And how do we get x by itself, guys? Divide both sides by what is currently being multiplied by, meaning x. And so it's going to be 9. So you simplify here using integer laws. It's going to be negative 4. Put a box or a circle around that because that's part of your answer. So that's basically just finding the x-coordinate if you're thinking about graphing. Okay? Then what we're going to do, just to save room, I just move this up. And I'm going to say sub x equals negative 4. And it doesn't matter which one you want to sub it into, equation 1 or 2. I'll always choose the easiest one. So I'm going to say into 1 because it's got smaller numbers, less room for error. So wherever I see, just let me do this for a second. Here's equation 1. Okay, and it says wherever I see an x, I'm going to put negative 4. So I'm going to erase my x, and I'm going to put negative 4 in there. Okay, now I'm going to solve for my y. So it's going to be 4y equals 4. Take the negative 4 over, becomes positive 4. So I end up with 4y equals 8. Divide both sides by what y is currently multiplied by, which is 4. So y equals 2. So now, folks, I have done all the work. I just need to do my, therefore, solution x, y equals, make sure you go in order, negative 4 and 2. Now, ladies and gentlemen, this is like an 8-mark question, so there's a lot of steps. So you're going to be marked on your process throughout this unit, okay? So if you're wondering, Miss R, why is this taking up so much room? Because there's a lot of steps in it. And yeah, these are worth 8 to 10 marks, okay? This is worth 8, and when you have a check, it's going to be worth 10. And we're asked to check it, so let's check that. Okay, so to do a check, I do left side, right side. Okay, so there's equation 1. And we're going to do equation 2. Okay. So left side equals, for the first one, it equals x plus 4y. And the right side equals 4. For equation 2, it's equal. The left side equals negative 2x plus y. And the right side equals 10. Go back to the original question, folks, not the one that you rearranged, okay? All right, sub in our values. So we've got negative 4 plus 4 times 2. Negative 4 plus 8 equals 4. So far that works. Let's do the second one. So negative 2 times negative 4 plus y, which is 2. So negative 2 times negative 4 is positive 8 plus 2. 8 plus 2 equals 10. Okay, don't forget your communication. Since left side equals right side for both, therefore, solution Negative 4 and 2 is correct. Awesome. All right, let's move on to a little harder example, okay? Example 2, okay? So taking a look at example 2, equations are given, so the next one is to label 1 and 2. All right, now folks, let's try to figure out how we can rearrange or isolate one of these variables so we don't have a fraction. If I take a look at example or equation 2, if I rearrange for x, do you notice there's going to be a fraction there? And if I rearrange for y, there's going to be a fraction there. So I'm going to try not to use the second equation, I'm going to try to use the first equation. If I rearrange for x, do you notice I'll have a fraction? But if I rearrange for y, do you notice that will eliminate? So I'm going to focus on the y. Okay, so we're going to go over here. I'm going to leave the 2y where it is. And I'm going to take 20 and bring the 6x over. It's going to become minus 6x. Everybody good with that? And to get y by itself, I got to divide everything by 2. So we're going to end up with y equals 10 minus 3x. That is what we're going to substitute in. So we're going to go sub y equals 10 minus 3x into, since that was the first one, you got to sub it into the opposite, which is into 2. So I'm going to rewrite equation 2. Wherever I see a y, I'm going to rewrite and put in 10 minus 3x. Okay? Then we're going to simplify that using distributive law. Okay, collect like terms. And watch, we can do a couple steps here at a time. So watch what I'm going to do. 2x plus 9x is 11x. I know I got to get x's on that side. So in the same step, I'm going to take that negative 30 over and make it a plus 30. Okay, so I got 11x equals 33. How do you get x by itself? Divide both by 11. And x equals 3. I'm comfortable, ladies and gentlemen, at grade 10. If you want to go right from here to here, you don't have to show me your divide by, unless you need it to help you. Okay, so we've already got one variable solved. So now we go sub x equals 3 into, what's the easiest one in this? For 1 or 2, I'm going to sub it into 2 because it's got lower numbers. So if I see an x, I'm going to put a 3. So I've got 6 minus 3y equals 3. Negative 3y equals 3 minus 6. Negative 3y equals negative 3. Divide both by, careful here, negative 3. And negative divided by negative is a positive, and 3 divided by 3 is 1. Okay? And then don't forget your concluding statement. Therefore, solution xy equals, sorry, I'll put the equals down below. There's not enough room there. Equals 3 and 1. All right, getting a little harder here, folks. It says, how is solving different with fractions? Oh, it looks scary, but all we need to do is remember we just got to clear the fractions first, just like you did in grade 9. Okay, it's equation 1 and equation 2. You might want a different color just to help you with this. So for this example, 3, notice you've got, for the first equation, we've got a denominator of 2. We want to eliminate it, so we're going to do the opposite of divide, which is multiply. You're going to multiply every term by 2. Okay, then you're going to simplify it by going 2 times x is 2x. Got to get rid of the denominator, so 2 goes into 2 once, it goes into 2 once, so you're just left with plus y equals negative 3 times 2, which is negative 6. Notice that we've just multiplied every term by 2. That doesn't change the nature of the equation. It will still graph exactly the same. Okay, let's take a look at the second example. So that's still, folks, that's still equation 1. Okay. Now what we're going to do for equation 2 is figure out how do we get rid of the denominators, which are 3 and 6. So what number does both 3 and 6 go into? And that is going to be 6. So you're going to times every term by 6. And we're going to look to simplify here. So 6 goes into 6 once. It goes into 6 once, so that cancels out. That's x. Watch this other one because it's kind of tricky. 3 goes into 3 once. It goes into 6 twice, so you're left with 2 times y, which is 2y. Okay? Equals 2 times 6, which is 12. My biggest error here, folks, when doing these problems is people will multiply the fraction ones through, but they'll forget to multiply the constant ones through. So please make sure that you do that, okay? All right, now we've got two equations that don't have fractions. So we've got 1 and 2, and we need to rearrange 1 for a variable. Well, this looks like easiest to get this one arranged for x. Or you could rearrange number 1 for y. So I'm going to go x equals 12 minus 2y. I'm going to write down sub my rearrangement x equals 12 minus 2y, and because that's equation 2, I've got to sub it into equation 1. So I'm going to rewrite equation 1, and you can use the simplified one there. And wherever I see an x, I'm going to put 12 minus 2y, but don't forget this other plus y here. It's part of the equation. Okay? Now we're going to simplify this. Oh, I need some more room. Give me 1 sec. I apologize. I ran out of room. Sorry. Give me a second, please. That should do. Hopefully this will work. There. Apologize for that, guys. So let's finish this up. Now, distributive law gives you 24 minus 4y plus y equals negative 6. Okay, collect our y's here, folks. That's going to be negative 3y equals negative 6. Take the plus 24, bring it over, becomes minus 24. So you have negative 3y equals negative 30. To get y by itself, you divide both by negative 3. So y equals 10. And again, you can go through that. Just make sure you got your integer lines. But by all means, if you need to put down divide by 3 on both sides, go for it. Whatever's going to make you be more successful. Okay, next step, sub y equals 10 into, what's the easiest equation? We got to go back to the fraction one because we got to sub it right into the original. And I'm going to sub it into 1. Okay, so it's going to be x plus y over 2, which is going to be 10 over 2 equals negative 3. 10 over 2 is 5. Get that 5 over on the other side. So x equals negative 8. Don't forget your concluding statement. Therefore, solution xy equals negative 8 and 10. Great. All right, folks, here's your homework, page 132, 3ACE, 4ACE, G, 6AC, 7AC, all of 8, and 9. This is going to give you lots of practice, but I'd like you to flip, before you turn off your video, I'd like you to flip so we can go over the one examples together. The ones that you're going to start with, ladies and gentlemen, are a little easier than the ones we did in class, so I don't want you to get frustrated. So let's just go over 3A, for example, okay? So for 3A, we have y equals negative x plus 3. It's going to be equation 1, and this is y equals x minus 1. Please make sure that you've written them down correctly and that you haven't copied with an error. I'm famous for doing that myself. So, all right, so ladies and gentlemen, what's different about these is they're both rearranged and they both have a variable isolated. So I don't want you to be confused about this. We just don't need to rearrange any equations. So we're just going to say sub 1 into 2, or you could say sub 2 into 1, it doesn't matter. Okay, so what does that mean? If I'm subbing 1 into 2, wherever I see a y in 2, I'm going to sub in the value of y. Another way to think about it, guys, is left side equals right side for both. And if both the left sides equal y, then both the right sides have to equal. So just let me show you this. I'm going to go y equals x minus 1. That's my equation 2. But instead of putting y, I'm going to put the value of y from 1, which is negative x plus 3. Notice again, we don't have any y's there, so we can collect like terms. I'm going to move the x's over to this side first, so they're going to be positive. So we've got 1x here, take the other negative x over, bring it positive. On the left side, I've got 3 already. I'm going to take my -1, bring it over. It's going to be a positive 1. You can move from variables to one side to the other or constants from one side to the other just to make life easier. It's going to be, I made both positive, so it's going to be 4 equals 2x. So x equals 2. And you sub x equals 2 into whichever one you think is easiest. In this case, I'm going to go with equation 2. So y equals, instead of an x, I'm going to put 2 minus 1. Y equals 1. Therefore, solution xy equals 2 and 1. So folks, with these first questions we start out with, they're pretty easy. When both variables are isolated, then you just let them equal each other. Okay? And you can go right to this expression here, as long as you put down sub 1 into 2. Awesome. Have a great day, folks. And again, come see me if you need any help. Take care.